Hi everyone, welcome back. Today we are going to see about the heating and cooling curve. So what is the heating and cooling curve of an electrical drive? So during the operation of any electrical drive, the various losses it takes place like the copper losses, core losses and windage losses, etc. So during this operation, it produces these kind of losses, but these losses, it produces an heat. Due to this loss, the heat which is produced inside the machine. So because of this production of heat inside the machine, the temperature of the motor gets increases. The temperature of the motor gets increases. The first point, so during the operation of any electrical machine, various losses like copper loss, core loss, windage losses, etc. are produced. So because of the production of various losses, the heat is produced inside the machine. So because of the production of heat, the temperature of the motor gets increases. Okay, so when the temperature it reaches the ambient value, that is the heat which is generated, which is equal to dissipated. Once it reaches the ambient value, so the further heat will be dissipated as heat. The further heat will be dissipated to the surrounding medium. Okay. Once the heat dissipation is proportional to the difference of temperature of the body and the surrounding medium. So it is according to the thermodynamics law, when the heat is always transferred from the hot body to cold body, not from cold body to hot body. It is based on the machine heat and the surrounding heat. If the cooling is not provided, then the motor can dissipate heat to this surrounding medium. For example, in some of the applications, they are using the oil as a cooling medium, water as a cooling medium, air as a cooling medium, so gas as a cooling medium, etc. So once the heating is not, when the cooling is not provided, then it will be dissipated to the surrounding medium. Okay. So in this heating curve, you can consider an homogeneous body. What is homogeneous body? For example, now we are cooking then rice. If you have taken one sample, if the one sample is boiled, all the rice will be boiled. Am I right? So this is an assumption. It is because of an homogeneous body. In a homogeneous body, wherever you can measure the temperature, the produced temperature inside in the particular body is always same. That is called an homogeneous body. Okay. So here normally heat developed by the machine which is equal to the heat stored inside the machine. After that, the heat will be dissipated to the surrounding medium. Just you can imagine a water tank which is located in the top of the in first floor or wherever. Now we are switch on the motor, then we are pumping the water. So the initial tank is empty. So now we are pumping the water to the tank. So the heat will be developed. We are pumping the water. Okay. So the pumped water will be stored inside the tank. That is called the heat absorbed by the machine. Plus, once the full heat is absorbed by the machine, it reaches the ambient value. So once the water tank gets full, then what about further? The water gets overflow. So that once the machine reaches the ambient value, the further heat developed will be dissipated to the surrounding medium. So the heat developed is nothing but W into T. W into T. W is nothing but the power loss during the small interval of time. The total losses inside the machine during the small interval of time, which is equal to heat absorbed, Gs into d theta. Gs into d theta. So here the heat absorbed, G, the mass of the machine, specific heat stored capability with respect to the change in temperature, plus A lambda into dt. A is nothing but the area, and lambda is nothing but a rate of heat dissipation during the small time interval of t. Okay. On the cooling curve, if the machine is switched off or when the load is reduced, the machine gets cooling. So then there is no heat generation. When the machine is turned off, then there is no heat generation. Only the stored heat will be dissipated to the surrounding medium. So here the already developed heat plus already stored heat will be dissipated to the surrounding medium. So here, so during the heating, while operating the motor, the temperature gets increases to this ambient value. Once the motor is turned off, again the machine gets cooling. The machine gets cooling. So this is called an heating and a cooling curve. And this is an assessment. This is an assessment. So the Newton's law of cooling is used to determine mass of cooled object, temperature of an object after a given time, volume of a cooled object, pressure exerted by a cooled object. So put your answer in the comment section, and these are the few reference books. Thank you.